So in order to get a gauge of where folks are, I'd like to ask everyone to join me on the Google Doc that is a project tracker, and I'll show you how this works. So here's our screen. I apologize for being behind on getting everything uploaded and organized. I'm feeling overwhelmed with my 6 classes a bit, so I put a bunch of time into one, and then I have to kind of let some of them sit for a little while. So remember, if you get stuck, call me. Email, I'm a couple days behind on email as well, so you can always get my attention if you just give me a ring. So here's our website. Let's jump to 245, and then you can join me on this master REPL and work tracker. It will pull up this. It's fun to see everyone jump on. Got some dolphins and coyotes, dragons, a goose. So what I did was I made a second tab on the bottom called Project Tracker, and I copied your first names, your public names, from the first tab and just moved them over here. I guess the better way to do this would have been to do a function. So better way to do it is this. There, okay. So this allows me, file 20, this allows us to see kind of where folks are. And so what I'm gonna ask you to do is just jot down in the status on 9 September column right here, kind of where you are. So you could say, let's actually, I'm gonna make this wider. I'm gonna enable text wrap. So Loretta could say something like, have basic menu working, stuck on user input, that kind of a thing. So this will allow me to get in a snapshot of where folks are, and I can try to adapt our group building there. So let's take a minute and do that. The access URL is going to be to the whatever file in your REPL contains your main class. So if I come back over to my REPL here, right now I'm just coding in one file, and part of our class example will involve linking multiple files, and we'll also touch on how do we adjust the compiling so we can compile single files, So if main is the one, I'm just going to grab the main URL to the main, and then Loretta could post it in there. And so when you are ready, over the next couple of days between now and Sunday, so when Loretta's ready, she'll just say yes. If you are at a point where you feel like you can't do anything else on your own and you need help, you could put that in here and say, you know, as done as I can get. Need help. You know, things like that are useful for me. So one of my the kind of the trade-off is I sometimes get behind on stuff or don't get things uploaded, and the good side for you is that you've got some flexibility in that people are at different levels of C++, and so I'm not especially for these first few projects, I want to see how far you can get in the time that you're given, and I don't want shouldn't panic or have distress if we feel like we didn't make it through all of the requirements. I don't want this to be a stressful experience. I want it to be a learning focused one. So that's a little note on the updates. So cool. This Google Doc, this stuff works pretty well. Good. Good. Got some menus. Figured it out. Okay. And we got a few more folks trickling in, I think. And then when I'm in screen share, I can't see very much. So take one more minute and kind of get your workspace set up there.
How do I access the docs?
The doc is on the within our homepage. It's sitting under here. It's right here under Core Resources, Master Repo, and Work Tracking Spreadsheet. I'll also drop it in the chat. That was Caesar, was it?
Yep.
Getting to know some voices. Welcome if you just popped in. We're updating the work tracking sheet, so it's the second tab on this Google Doc project tracker, and dropping a little note on how you're doing and if you need any help. And so I'm gonna just tweak this. So we'll say we're aiming for Sunday at morning light. So Sunday morning. Anyone do anything interesting or notable over the long weekend? There was barbecuing going on in Swissvale, lots of smell of cooking meat in the air.
I'm currently in the middle of a vacation at a cabin, but I came home so I could come to class. But I'm having a hard time. For some reason, mine isn't updating with any of the information with the new row that you just put in and stuff. Column.
Oh, interesting.
I don't know. It's just still back on the last one is the resource. So I don't know.
Try doing an F5 and refresh.
I did.
And so you're saying, are you on the second tab on the bottom, the project tracker tab? Check that.
Yeah, maybe I'm not.
There's the main tab on the, when you load it, you have the
I got it. Thank you.
Good. I'm always extolling Google, and I'm like, oh no, we can't have Google going the way of Microsoft. So this is good. It's amazing how bad Microsoft's OneDrive is. So many little bugs in it. Okay, good. So I'm gonna let that trickle in, and then grab your books. We're gonna be book connected. What I did on our schedule is I made a note that if you don't feel overwhelmed with where you are in C++ so far, I'm going to encourage you to try one of our extension exercises, which is implementing class-based work on your team optimizer. So what I did was, that's really ugly to have those long lists there. Let me just clean that up here for a second. Data structure schedule. Let me try. Let's do style equals. Okay, and then this guy. Oh well, Hope to do that later. So here we are on week 4. So I made a note that what I'd like to work on today is class-based C++, Reusability Chapter 9, classes, etc. as our guide. And then I made our note, please have your team optimizer in a fully baked form by Sunday at morning light for instructor review. And then I will, based on where I see people are in their project, I'm going to do a pass through this schedule. I had to kind of put this class on a little bit of a back burner when I got all the other 5 of my classes going this past week. So, and thank you for your patience. All right, so I think that's it for housekeeping. Any other, looks like we're all making it into the spreadsheet. Any other problems there? Okay, sweet. So let's get our chapter 9, and this is, what we're doing is we're taking what you learned in Java object-oriented, so the CIT-130, and we want to transpose the idea of custom typing and move it over into C++. And so this is a new process for me as well in C++. I know it deeply in my heart in Java, so it'll be, I can kind of learn along with you in this process. So I'm going to start with our basic idea, and then we'll jump into the code and explore a little bit on classes. So we've got an hour left, so we've got to make sure that I stop at 1:15, so we have a little bit of time to do this small group work. So try to keep me on schedule there. Ryan Artifact, if you're out there, if you can help be my timekeeper, that'd be great. Okay, so custom typing. We've learned that C++ was adding object-oriented programming onto C. And can someone give a quick summary of what we mean by object-oriented programming? What are we, what's the design goal in creating custom types or objects?
Creating reusable sets of properties or functions that can be applied to many different classes.
Great, I love that. The idea of reusability. Who was that was speaking?
Benjamin.
Hi, Benjamin. Great. So reusability of the 2 things that we've put in classes. So we've got variables that can store single values or objects, as well as functions that operate on those classes' variables. And this turns out to be a fantastically useful way to organize software code, as hopefully you saw in your 130 process. Let me turn off my screen share here so you can see full screen. So our goal is to be able to not only have reusable code, but also to create a representation of an object in the real world that we're trying to manipulate in our program. And it's very handy to be able to group all the variables and functions that we need into an entity that can be referred to with a single variable. The object in memory can get us access to all of our functions and variables. So with the Team Builder project, where we left off last week was we were storing our vector of candidates. And what was the type we were using for candidates last week as a class?
It was either strings or vectors.
Yeah, so we would say the vector would be our list structure, and so we were making a list of just the candidate names. And so the drawback to that, so we could think of the vector as the set, not the set, but the list of strings. So if we had various candidates whose names we stored, here's our standard names that I use. My computers all have names. So the limitation of this is the only thing we had in each element of our vector was a single string object. And so we were limited in the amount of information we could store about each candidate because we were using a relatively simple object inside of our vector. And so what I'd like to work through as a group today is how could we take the next step and say, well, instead of just storing the individual names, what if we could store an entity, in this case, an object that contains a variety of pieces of information about that candidate. So instead of just having the name, we could have something like, we could have the name Dolores and then other attributes like, in my case, I was building a team for working on a crane, so I might ask, how many years of experience do you have working with hoisting stuff? So we could store a value like an integer. We could store any other custom type inside of this object. So in other words, each element in our vector could then become our custom type, which I want to design up here. So what if we, let's do an example. We'll name it, I shouldn't do candidate. I'm going to do, because I don't want to do your work for you because that takes all the fun out of it. So I want you to be thinking about how we can adapt this to candidates. So I'm going to actually make an object called crane. So in your notes, let's remember our familiar structure for diagramming a class. This should be somewhat familiar from your 130 days. This is referred to as UML, or Universal Markup Language Notation for classes. And this is very common if you walk into an office where people are coding. There's a good chance you'll see stuff that looks like this on the whiteboards, hopefully. So the convention would be that we have member variables listed in the top box, and then functions or other, I don't know if C++ officially calls them methods or not, but it's very common for a function existing inside of a class to be called a method of that class. So we can say, well, for a crane, what information would we want to contain about the crane? And then we'll touch on functions here in just a second. So we'll try crane together, and then I'll invite you to think how much you do this with a candidate object. So instead of storing just their name, we can store a variety of information about it. So a crane, we could say, could start by saying, we could have a string called style of crane. It's a bunch of different ways you can build a crane. We could store a numeric value of max hoist, max hoist weight. We could have another int storing how far out from the pole the crane can swing, so maybe or swing radius. And we could have a Boolean for if it's powered or if you have to crank it yourself. So we have these 4 variables, and we want to include it in a class called crane, and then we'll touch on functions here in just a minute. So if I spin up my REPL, let's jump in there. I'm also going to pull up the .cam so you can see what I'm looking at. Let's try this. Okay. So I like Strostrup's discussion of classes. Let's drop our. It gives us our basic syntax here in 9.2. I'm always thrown off a little by the C++. He likes to squish. He likes to squish his functions into the same line, which is different than standard Java notation, but the idea is the same. Now, when we build a class, we're declaring a block. So we give the name of the class, or we use the identifier class. Not the identifier, the keyword class, and then we give it a name. The convention in C++ is that the library classes still get their lowercase, but custom types get an uppercase letter to start. In Java, all of the classes, all object types were uppercase, so just a little nuance there. We have the notion of access rights within a class, which is something that we'll be developing over the semester. A public variable or function allows external users of the class to engage with those items directly, whereas we can have some that are private, meaning they're used internally by functions within the class that we don't ever want to let an outsider just jump in and use. Outsider meaning the client or the code that's using our class. So it's less about kind of hacker security and more about how do we only expose to the users the particular variables and functions that they actually need, and the internal guts stay hidden behind a private wall. And so that's what he demonstrates here in 9.3, which is we can also declare private members, which we call implementation details, used by members of this class only. And so as we think about what that might consist of for candidates, we can build that out together. So let's just try cooking up one of these together, and then we will start accessing it. So let's open up our REPL. And jump back to a screen share. Did anyone design cool classes in 130 that they can remember that they might want to try to model over in C++? Anyone do anything creative?
I think at some point I made a class to represent a pizza. Just to prove a concept that I could make classes, but like.
Yeah, perfect. My Java students, we model donuts. So I go and buy a bunch of donuts, and it's a good example. I'll just show you quick because it's they're kind of cute, and it illustrates the concept quite nicely. So we can, if we had Ryan did a pizza, we did little donuts. So the idea would be a donut class represents all of the elements, or it represents the characteristics of a particular donut. So we had, where's my good donut outline? So in our donut class, we were able to simulate how we'd simulate eating a donut by a little monster. And so a donut knew how much of itself was remaining. It had a name, and then the methods that we used were simulate eating, so I could tell a donut through one of its methods or functions, hey, I'm eating you, and I would pass in how much of you I'm eating, and then I can ask the donut for how much of yourself is left. And this is, it's not as silly as you might think. Like with a pizza, if you were building an ordering system for a pizza, and you had a website that allowed you to customize a pizza, you would absolutely have an object that the user was manipulating the variables on, and then you send that object to the cooks and display the value of the member variables, and then they turn that into an actual pizza. So this turns out to be an incredibly useful design concept, and we can also have fun doing it. So here we are in my main.c++ file from last week, and I was tinkering around with a candidate class that I'm going to let you design. And now what I mentioned that, well, what do we do in REPL if we want to have several programs that run in the same REPL, and how do I connect them up, or how do I use multiple files? Is it the case that we didn't do this as a whole class yet? I think I might have done it individually with someone, but not the whole group. Not the whole group? I don't think. Shake heads or something. Not yet. Okay, I'll take that as a no. So what I want to be able to do is build a script that tinkers with my crane in a separate file. So I'm going to make a new file, and we'll call this hoist.c++. And I'm going to show you a couple of approaches. So one approach would be that we only have one main function across all of the files in our REPL. And that could live here in a file called main.c++. And then we use that front door of our program to call whichever functions within the set of files that exist that we want to use in that particular moment. So it's kind of like we have one big program, and we turn on and off functions that we want to call from main. And so I'm going to demonstrate that here in just a second. Like we did before, how we can turn on and off the functions that we want to run in this same file, we can do the same thing with multiple files. And to do that, we are going to use an include statement at the top that instead of including something from the standard library, we can actually include other files in our include directives. And if you give it a minute, it'll recognize, oh, okay, I see another file in my directory called hoist.cpp. And what will happen when the compiler reads through these includes is the contents of this entire file will get inserted at exactly the spot that this include exists. So whatever is defined inside of hoist CPP, we can start accessing directly after this include directive. One thing to note, another difference between Java and C++ is C++ is not picky about file extensions. Like Java, the Java compiler will not, it will spit out files that do not end in .java unless you do some pretty intense backflips. But C++ officially is agnostic about how we suffix files. You'll often see files included that just have a .h for header. That's common, but just realize that there's nothing particularly magical about .cpp other than its convention. So what we'll practice here is, let's try defining our crane class. So we'll just say class crane, and we'll open it up, and then we will define some public members. So string style. Now in this case, for this particular file, we will have to re-include the headers for our class use from main.cpp if we want to use those references in our hoist. So I'm going to use string, so I'm going to include my string. And I'm also going to include vector again. And then using namespace std. And so once again, this allows me to not have to prefix each use of that class with the namespace operator. Just it tidies up the code a little bit. So I can say string style, and let's do our int max hoist weight in pounds, and we'll say int swing radius degrees, and bool is powered. And so these are public members, and we'll start as simple as possible without any functions just yet. So once we've declared class crane, we can do a function for demonstrating the use of that crane, and then we'll try to make a vector list of them. Let me check my time. Oh, we're going to have to go fast here, about 10 minutes. So let's define a quick little function. In this case, we'll just call it void crane demo. And so remember our basic object structure of the magic dot operator. So when we define an object, we can say crane, first crane. We've said I want a variable that is typed crane, and I'm going to refer to it with first crane. So once I've defined that, my magic dot allows me now to get access to its public members. Now, if there were components about the crane that we wanted to make private, let's just demo that here for just a second. So what are the internal structures of a crane that we don't ever need to let anyone else know? So maybe it would be, what would be a good example here? We might have a,
Maybe the cost of the crane?
yeah, maybe an internal cost. We could do double cost. We'll just demonstrate it here. I want you to see that private members don't, I thought that would not show up.
It's named Frist instead of First.
Oh, thanks. We're still seeing that member. I bet that will say, so it shows up in the list, but you're not allowed to access it from outside the class. So in NetBeans and Java, it doesn't even show it to you, and here in REPL it does. So we can load up our first crane and say first crane.style. And so in this case, we could give it a string value of htruss dot max hoist length. So the highest I guess if we model my crane, this was a cable hoist, and I've listed, I think the wood was like 780 pounds. Okay, let's work on my spelling here, Eric. That would be useful for everybody. First, I did it again. First K. Sorry, everybody. First crane, swing radius in degrees. So in my particular crane, I don't have any swing yet, and dot is powered. So in this case, it is powered. So we can see this. I should have done my comments before. So in this case, we create instance of crane without a constructor, and we'll do constructors here in a minute. And then we are assigning values to public members. And then let's just make sure that we can get these values back out. So let's include our input-output utilities. And so let's just make sure that we can see this working. So we could say cout first crane dot style oops. Let's see them pop out. So max waste. Go ahead and just, I want to get a sense. Raise your digital hands if this feels familiar from 130. If the object dot approach is, it's like, yeah, this gets me back into the land. Okay, excellent. That's what I like to see. It's fun. I get little green pop-ups every time you raise your hand. All right, so let's jump back to our main and just try running crane demo so we can see it work. So for now, I'm going to cancel out map practice, and not cancel out, comment out map practice, and say initiate show crane test. So we should be able to access our crane demo function from inside main. And we're loading. Oh no, failed to connect. Ah, good job, Repo. All right, and now, so this is set up to run main.cpp by default. So we should be able to see our crane output. Multiple def in a crane demo.
Did you create the crane object?
I thought I did here.
Don't you have to do it in main? Or no?
Perhaps I'm not. In my test, I got this to work. Let me jump over to my practice script. Multiple definition of crane demo. Oh, I think probably when this does the include, it should give me a definition of crane demo. All right, we're gonna try the other approach and then we'll work backwards. So if I just want to, so let's treat this hoist.cpp as its own program, in which case it's going to have a an int main, and we will compile it by itself. So let's try this. And this is also getting to what we wanted to practice. I really want to get you a half hour of tinkering with showing off with each other. So, so here we are. Now if we try running this, it should say you can't have two mains, and then we'll fix it. So by default, once again, our Linux machine is compiling C++. Yep, previous definition is here. So all we want to do is repeat this command, and instead of compiling main.cpp, which is our previous test file, we just want to compile hoist.cpp. And this flag, the -o, is telling the compiler what we want the output file to be called. So in this case, we're going to actually code it up by ourselves. So we'll say the name of the compiler is clang++-7. We give it this flag, and then we tell it which standard library we want to use. And so now the -o flag says, I'm about to give you the name of the output program. And so in this case, we'll call it Crane. And then we'll say, what do I want you to compile? I want you to compile hoist.cpp. So now we are bypassing everything in main.cpp. And we got no errors there. So what we see here now is inside our directory with ls, that just means list what's in there. We see here's our two C++ files, and here's our executable program called Crane, which we can run then with /crane. And we see what we expected. So we got our cable hoist, style, max hoist weight, and swing radius. So this was very basic exposure to an object creation process and how to run just one file at a time. Any questions on what I did here? So these two flags stayed the same. The -o flag got changed to a new output file, and then you tell it which files you want to compile. So notice that when I hit run by default, oh no, I lost it. What it does is it compiles all the files in the current directory. So it included both files at the end of the command, hoist.cpp and main.cpp. So all we were doing was adjusting this. I encourage you to not copy and paste. I think it'll generally turn your brain to mush. It's useful to get muscle memory in the typing. Any questions on that right now? And running multiple files. Okay, so the last thing I want to do so that you have something to chew on then is, well, what if so you could imagine a candidate class being able to then store the particular attributes of the candidates on which you want to base your rankings and your assignments. And so once you have designed your candidate class, you'll want to put it in a vector. And so this is where the generic programming comes in. So let me give you the example with our Crane, since we're working with that and almost out of time. So let's do I've declared my class crane, and now I want to declare that I want access, global access to a vector or a list of cranes. So this is where I can say, like we did here with main, we had our candidate list that was declared in global scope. So we said, I want a vector that is a vector of string objects. The exciting thing, once again, about custom typing is we can say, I want a vector of cranes. I want multiple cranes, and I can call it crane list. So in this case, we are declaring a global variable of type. It's still type vector. The list is type vector that holds our custom type of crane called crane list. And so in this case, we could then load up our crane, and then we can add it to our crane list, and we'll use our pushback. And so notice here it recognizes that it will be looking for a crane object because we've declared this vector stores crane. So what am I going to give it? What variable? Since it needs a crane. Am I going to type crane? Ben, you can't answer.
First crane.
First crane, yeah.
You'd answer. Yeah, so we give it our instance of crane, first crane. And so now our crane demo, so we can practice this. So we put our first crane in there, and then after crane demo is done, we could then ask the vector for to extract that crane. So we could come down here and say crane C assigned to our crane, go grab the first item out of that, and we can see that we can extract it from the list. So now the function above. So we could then say C dot, and see it knows, here's our crane. Now, when we're at compile time, it doesn't necessarily know what these values are going to be, but it knows what the definition of a crane is, so it will allow us to access through the type its member variables. So we could say c.style, and then just show our little, okay, and then could have just copied and pasted that down. Max hoist weight. So we'll say cout. Okay, so let's see that go. So I'm gonna do my same process over here, compiling by hand. Use pthread. CList and CPP. G would help. By the way, notice what I did. If you type a command, you can use the up arrow to get back your history. But unfortunately, what it puts in, it doesn't include it. What repo puts in for you, it doesn't include in the history. Okay, so that compiled successfully. And we can see that now I have a crane list program that's executable in my directory. So I can say crane list, and there it is. So we made an object, we put that object into a vector, and then we extracted it and did something with it. So you could imagine building a function that knows how to loop over your crane list using our iterator and pull out a candidate and compute some sort of you could think about a candidate score of some kind, and you could do some ranking and that kind of thing. So I wanted to give you that first pass. Next week, one of the things we'll jump into is working with pointers and references, which will be much more in C++ style. I want to get more comfortable with them myself before I try to teach it. So this is a rudimentary example, but it's enough for you to start tinkering. Questions for the group right now? Otherwise, what I want to do is give you a chance to join some breakout rooms and potentially help each other with some of your problems. And I want to get you a chance to do more interacting in a small group, because we have such a big class that I could imagine it's a little daunting. So questions for the whole group before we take about 15 minutes in some breakout rooms? Y'all so quiet out there. So once again, this is in the, I'm sending out my repo link if you want to bookmark that.